Welcome to this course, Software Development Technical Applications, VSMN20. It will be given in English because we have some guest students from abroad, and most of the material is in English as well, so hopefully you will make do. We are going to learn how to code engineering applications, all the steps, from designing the model, the user interface, the visualization, the report, presentation. So, implement finite element code from start to finish, reuse existing code and libraries that are available online, implement the user interface, and visualize input and results. So what you see here in the windows here are example of what you will be able to do at the end of this course. So basically create a complete application with a user-friendly interface with visualization parts, and also able to produce a report where you can send into a reviewer or something like that. The course plan is as follows. We will have 2 lectures this week, and also 2 exercises. Please check the Canvas page because the schedule is a bit different the first week comparing to the coming weeks. What we will cover during the course here is today, in the next part of the lecture, I will go through Python and the development environments that we are going to use. There will be lectures on matrix computing with Python. So basically how we do the things we have done in MATLAB before in Python. We'll go through Calfan for Python, which is, probably know if you have used the finite element courses here, you have probably used Calfan for MATLAB. We will use Calfan for Python, which is a similar toolkit with, I think, 98% of all the functions in Calfan are available in Python as well. We'll go through user interfaces in Python. We will do some lectures on scientific visualization using some applications that are commonly available online. Some perspectives on Python and programming. We will also have a guest lecture from one company involved in designing and developing engineering applications. And we will have, of course, exercises as well, where you can ask me questions, you can work with your assignments, and we will have also teaching assistant Philip Rasmussen that will help us out in the course. That's that. The course consists of a large project assignment. So the project, you will work on that during the entire course. There is 5 worksheets that you will work on, and then a final report. So there is one, you have to kind of work 1 week and turn in an assignment every week, but it's the same project. So can you build on the existing parts? So at the end of the course, you will have a finished program. You can work individually or in groups of maximum 3 persons. The examination is the approved assignments, of course, and approved final report, and the participation in the final seminar. So at the final seminar, you will be presenting your application, and you will also get feedback from your peers. So at the final week, you will exchange your applications and give comments on the other group's application. There is a Canvas page. I'll show you here. Looks like it. I hope you all have gotten accounts for Canvas and be able to get into the course page. So here you will find information, general course content information, the upcoming lectures, installation guide, which you probably perhaps have started with already, how you install the software that you require, then the course material, web-based material, literature, and then there will be modules for the different lectures, and also links to interactive lectures as well. And I will tell you when there is an interactive lecture. And that means that you can open the same PowerPoint on your computers here and work alongside what I'm showing on the screen here. So you can actually do the same exercises during the lecture. I will do that on the Python exercise in the afternoon. So Canvas is an important tool for this course. All the assignments will be given in Canvas. You will get feedback in Canvas as well. So that was Canvas. Literature. There's a Swedish book, unfortunately, Infodion's Guide to Python, which covers many of the topics we have in this course. There will be online documentation in the Canvas site. There are some other books here as well. The worksheets are quite detailed in the beginning. There will be less details in the coming worksheets after a couple of weeks. You will also get example source code from me. For example, for the user interface parts, you will get examples of user interfaces that you can model your own code on. So you will have a lot of material to work on as well. Software, we will use a Python distribution called Anaconda. And the reason we use Anaconda because it contains all the numerical libraries that we need in this course. So you can download Python without Anaconda, but it doesn't contain the numerical libraries that we need to do computing. So Anaconda is an optimized distribution of Python. You can compare it with MATLAB. You download MATLAB, you get all the toolboxes in MATLAB in one package. And Anaconda is the same thing. We will use something called GMSH, which is a mesh generator. But fortunately enough, it's installed with Anaconda now. Before you installed it separately, but now you install it with Anaconda. Colfin for Python. You install that also inside the environment which we're going to use. So you execute a command and Colfin will be installed for you in your own computer. In the beginning, we just will use only Python, so we don't have to do much Colfin for, it comes in 2 weeks, something like we start with Colfin. So the project you will do, you have to decide for one type of project. So you can do plane stress, two-dimensional heat conduction, or two-dimensional groundwater flow. You pick one of these. You don't have to implement a general finite element application. You implement one of these problem types, and the application should handle one of these. Here you develop this on a PC or a Mac. And as I said before, the development is divided in the worksheets. So every worksheet has a certain part of the program. So for example, in the first part, you will do the initial computational model. Then you will add net generation, mesh generation. You will add user interface, visualization, and so on. So it's a stepwise process here. And just to give you an idea of how the program is kind of built up, and also the numbers here are the worksheets. So in the first worksheets here, first is Python, so it's a bit generic here, but in worksheet 2, we will start with defining the finite element model that we're going to use. So implement groundwater flow, heat flow, or stress computations in Colfin. And we'll bundle them up together in a model. So in 3 here, we will define a parametric geometry here. So we describe our geometry with dimensions and materials, if there is a hole. And we also will do generate a mesh here automatically, and also do the computation here. So the biggest worksheet perhaps is number 3, which basically goes from the small model in 2 to a larger model where we describe the model by a parametric geometry. And then in worksheets 4 and 5, we will do the user interface. So be able to give the measurements and the sizes and the materials in a user-friendly window. And then in 5, we'll also do the visualization of the model and also produce results. So this is the kind of large conceptual model of what we are going to do. In code, it can look like something like this. So the things that we are going to implement ourselves are, this is the plane stress here. So we have a plate solver, we have the plate results classes here, we have the model here containing the computational model, we have loads and boundary conditions, materials, and then we rely on external libraries here. So we have Colfem here to implement the computational solver. We have visualization libraries like Matplotlib, VisVis, which we are going to use when we visualize the model. We will do the window or the user interface in something called Qt, which is a user interface library. And the mesh generation is done by GMSH. You will never need to call this directly. This is implemented in Colfem. So you describe the geometry, and then it will generate the mesh for you automatically. So this part here is the finite element code. This is the user interface, and then we'll rely on these external libraries. The worksheets are available on this location here, read the docs, and we can go into here. And here you can see on the left side here we have worksheet 1. We will start slowly with just Python, so there will be no matrix computing or anything in worksheets. It's just kind of to get you started in Python, because I know that all of you haven't done Python, so we'll start slow and go through it. Python is very similar to MATLAB, so it's not very different. You can do most of the things you can do in MATLAB in Python as well. So here are some simple tasks here to implement during this first worksheet. Then in worksheet 2, we'll start actually building our finite element model. So here you go through step by step. It tells you basically what you need to implement, gives you some example how to start. And also, if there are some, like this, 3 dots, that means that you have to fill it out with more code. So it's those 3 dots shouldn't be entered manually. It's just a kind of illustration of the code, that there are more things to be inserted here. You can see here as well, there are the element degrees of freedom here, for example. And then you go through and implement all these parts of the code, the model solver. So it's very step by step in the first part. And then it will open up and be more open in its way. So next here you define the geometric model. Number 4, you will go through implement the user interface. And worksheet 5, you will do a parameter study as well. And then there are some instructions here on the final hand-ins as well. So this is the kind of where you find all the information for this project. There are some guides here as well that will be updated continuously. Here is, for example, how to print tables in Python in a nice way. Here are also some links. I will update. I will publish the updated version of this. There are more links in the latest version here. So here are the worksheets. And all worksheets are available, so you feel free to work more if you want. I will try to, if there are any bugs, I will try to fix them as soon as possible in those worksheets as well. So you can work forward if you want to as well. So, and then we have a question. Many wants to, but I want to do it in my own way. And that's perfectly okay. The important thing is that if you want to code this application in a different way, you have to still fulfill the requirements of the assignments. So so you need to look at the assignments. So the application needs to do the same thing as the project and the worksheets. But if you have an idea on how to implement this in a different way, it's completely okay to do that for me. There is also, for those that want to do extra work, there is also additional worksheets if you want. So you can do extend your applications with more functionality. Yes. But as I just to summarize here, you don't need to follow the worksheets, but you need to solve the basic You must provide a graphical interface that can handle the input that is for the application. Also, the computational model must be able to perform the same as in the worksheets. You need to do the same visualizations, and you still have to do one submission per week. So, and that submission per week, that is because I will try to continuously give feedback on the code that you write. Perhaps not so much for the Python part, but for the other parts that you, I will try to guide you in certain ways. So that's the important that you need to submit once a week. So I have another slide deck I want to go through today before I go into Python here. And that is why we do this civil engineering, for example. Perhaps geared towards the V direction, but I think you can apply it for other codes as well. So what you can do with coding, even if you don't want to or going to be a developer for developing engineering applications, you can still use your knowledge in programming to do many different things. For example, to automate repetitive tasks. So if you have your application or engineering application, it supports scripting language, you can do a parameter study. So you can change a parameter, recompute without making all the manual changes, which also reduces errors. If you can code your input parameters in code instead of saving it as files, you can reduce the errors when you run it again, so you can reproduce the same results. You can automate report generation by coding that into a program. You can do data analysis and visualization in different ways by using libraries that are very good at visualization. Parameter study, as I said before. And also increase the focus on the engineering profession. So you can, by automating things, you can do more things. You can be more efficient. So here's an example here. I have a Python script. Most engineering application and CAD applications have APIs, or application programming interfaces. That means that you can actually start engineering application from Python and talk to it from the code. So you can create a model, you can set the parameters, you can run your engineering application to do some modeling. You can call a finite element application with the same API to control that. And when you're done, you can talk to Excel to generate results in a single script. So Python can talk to all the applications here in different ways. How you do that technically, that can vary from the application to application, but mostly you can use Python to integrate them together. And you can write a report in Word. So this is in the importance of being able to code in engineering professions. And this is an example from actually the code that you will write at some point. Here, for example, you can create parameters of a model. You create the results here. You create a solver and you execute the solver, and then you can, here you can see how I do it. Excel writer here. I can actually output the results to Excel and save that to Excel in a script. And I can, of course, and here you can see you can get the results directly in Excel. And also, in many engineering problems, you work with multiple software packages, and combining these can be complicated. But as I said before, when we have APIs and applications, we can actually connect them together and let the Python script be the glue to create the workflow that sends data between the applications. So, for example, there's a groundwater flow problem here, which is actually one of the things that you will do if you select that problem type. So if I want to change the variables d and t, I can create my model parameters. This is just a fictive thing, so it's not. And then I create the ranges what I want to study. So I want to study d from 0 to 8 with 2 steps, t range here from 0 to 10 in 2 steps, and then I create a parameter space, and then I create to store the max flow here. And then I solve my problem. And then I can loop here over, create a loop here over D and T. And I execute the solver multiple times. I store the max flow in an array. And then I can plot the parameter surface here, write to Excel, and then I get a plot like this. So imagine that the solver here is an application, engineering application, any application. And then you just run that multiple times and you control it from Python. And here you plot a matplotlib here and you have Excel for reporting. And there are other applications. There is an application called FemDesign, which is from a Swedish company called Strusoft. And they have actually implemented this in their application. So here, this is C#. So they have an API that you can call from another language. But they also have, you can see they create materials, material names. You can create the dead load, the live load, and you can add elements. And the entire application is scripted. But they also have a Python interface. So you can do the same thing with Python. Yeah, so by using also programming and APIs, you can also create your own visualization tools. So like MATLAB and Python, there are NumPy and Pandas, which is for table-based data. There is applications called libraries called Vido, VTK, and ParaView that can provide you with additional visualization tools. I got some other examples here of Matplotlib. Vido can do 3D visualizations here in very simple, just a few lines of code. So this is a volume field, and then you can do volume visualization by voxels here. So you can see you carve out and you can see certain values in this voxel field. ParaView, which we'll actually go through in this course, is a free application for, it's like a Swiss Army knife of visualization. So it can read like 300 different input file formats, and you can process the files and create 3D, 2D, 1D visualizations very easily. Not very easy. It's a complex application, but it has compared with it's very when you know the flow, it's very easy to do this kind of visualizations. And then you can also run ParaView as a Python interpreter. So ParaView as an application has a special Python interpreter called PVPython that you can write Python code and produce the same visualizations here, but just with scripting instead. And you can actually generate from the graphical tool, you can generate the Python script for doing this. So you can create standalone visualizations from ParaView that doesn't require the user interface anymore. And then we come to optimization and AI. And many AI models need to be trained with data. And by having APIs and different applications, you can integrate these engineering tools into both optimizing the structures, but also optimizing AI models. So it's an important tool to kind of combine these together. And here are some other examples here of real-world things that they use the APIs to actually optimize these silos. So the geometry here is optimized by running Python scripts to kind of generate the geometry that you see here. You can read this later here. Yeah, and also you can integrate with CAD and BIM systems because they all of them have APIs that you can integrate to create data, create volumes. You can create and do parametric models. Another thing that you will see here when I start a Python course, Python lecture, is that you can use something called notebooks. And notebooks is a combination of a web-based tool for writing text, headers, combined with code. So you can actually see it as a digital engineering calculation that you can share with other people. And it's available Google has a free service called Google Colab, where you can actually create these notebooks and run Python code inside these notebooks, and you can share these notebooks with other people. And my lectures in Python are mostly done in Colab, so the links you have in Canvas will go to an interactive notebooks which you can follow along. So here is, for example, a calculation I've done for the flow of water in Skivab zone in Skåne. So you can see here that you can enter a Python code here, but you can also enter formulas and texts and images. And here you can see here that I installed CalFM Python here. And you can see I can combine text and code all over the place here. So then here I import the necessary Python libraries. And it's a very nice way of providing models to your co-engineers that you work together in projects. So you can run CalFM inside of a notebook as well. And here you can see that you can produce nice tables here directly from arrays. And just to conclude here, I will show you some applications that have been implemented by staff at structural mechanics, but also as master thesis students here at mechanics. So this is a master thesis work many years ago now, but a visualization of stresses on the mirror of the very large telescope. So the mirror is placed on actuators that actually can modify the geometry of the mirror. And this is just to model how that affects the stresses in the mirror as well. So we developed our own visualization tool for this. We also have had a master thesis working implementing visualization functions in CalFM for 3D visualization. So here is for visualizing. This is a beam here, deflection of a beam, using the Vido toolkit. We also implemented a geometry editor inside CalFM that you can open up to edit geometry that you want to do mesh generations on later. A couple of years ago, we did something called SketchFrame, which was an iPad application for seeing the forces inside a two-dimensional truss structure, and then you can, with your fingers, can change the load and see how it affects the structure. ForcePad you probably have seen in some courses here. Also an application that you can two-dimensional where you can paint with stiffness. Hakon was a commercial application. It's now available to download from Structural Mechanics. It's an application for simulating hardening of concrete. So when you pour concrete, it develops heat, and you need to control the heat development. And here you can simulate the steps of the curement process, and you can also add cooling pipes and insulation to kind of keep the development in check. And here you can see also you model super elements here in 2D. We also had a PhD student working on conceptual design here using something called a leap motion, where you can see it can recognize your hand and you can actually pull and press the model interactively. We have done visualization of fiber networks. So this is an old application, but now you can do this with shaders, but at the time it was very hard just to visualize cylindrical hair-like structures. So we did texture based here to kind of made them look like they were circular. So then we can visualize more structures. And then we also have implemented something called Objective Frame, which is an interactive three-dimensional truss simulator where you can actually also see the interaction in real time. So programming is important for the modern civil engineer. It streamlines workflows. You can optimize models with many different packages. You can replace hand calculations with interactive notebooks. You can enable machine learning as a tool in the design process. And you can create domain-specific interfaces to simplify frequent calculations. So this was kind of to give you an overview of why we should use this, or what you can bring with you with this course. So next I will start with a Python lecture here. So if you are interested to follow along, if you go into Canvas and you press Introduction to Python, you will be able to open this notebook. I'll give you one if you want to interested. What you need to do to be able to interact with it is up here. It says Anslut if you are connect. If you are not, if you just open it up, but you press connect and it will allocate a Python interpreter for you. So otherwise it's just a static page. But when you come to the interactive parts here, you need to have a green symbol here that says RAM. You are connected to Google Compute Engine somewhere in the world. So Python, a little bit about the history of Python. It's a relatively new language, or compared to other languages. It was created by Guido van Rossum in 1991. And he wanted a language that supported readability. So without any, the readability should be built in the code. And it should be able to write large application in a clear, logical style. What is a bit different from other compiled languages. So compiled languages are where you take a source code, it is translated to binary code or machine code and run directly on the processor. In Python, it reads line by line and interprets everything directly. It's also dynamically typed. So in C or other languages, you specify a type, int, double, float, and then you give a variable name. In Python, you just say variable a equals to 2. And if you don't have a decimal point, it will be an integer. So it's dynamically typed. It depends on what you assign your variable. The type is decided by the language. Another thing that is cool with this language, it actually supports any kind of programming style that you want. So you can do structured procedural programming. That is, you define your functions, your procedures, and use that as a basic program. You can do fully object-oriented programming, and you can also do functional programming, which is the kind of latest trend now. Python is developed in a foundation, and there is a community around Python that releases new releases of Python almost every year. The largest Python version was Python 2, which was released in 2000, and which is currently deprecated. So you're not supposed to develop new code in 2.x version. So the latest version of 2.x is 2.718, and no new development is done in that version. All new development is done in version 3.0, which was released in 2008. Also note that it's not completely backwards compatible to 2, so they changed a lot of things in the language specification between 2 and 3. You don't have to think about this because we are going to do 3. So we are going to use 3.11 in this course, or that is what comes with Anaconda. You can use any version in Anaconda as well, but 3.11 is the one that has most libraries supported for it. The main Python page, so where Python is kind of the core Python, is python.org. Looks like this. So this is the core Python interpreter. You can download that as well with the core libraries, and you can find all documentation for Python here as well. Anaconda Python is Anaconda is actually a commercial company, so you can buy a supported version, but it's free for personal use and for teaching education. So it's developed commercially, but it's free for use. It's because Python is open source, so you can't resell it however you want. So you need to kind of provide your changes back to your community. So language philosophy, I think everybody can agree on this. Also, beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. And complex is better than complicated. And then readability counts. So these are important things with language. And you will see how that is implemented in the language as well. Program structure. So a Python program is a text file. So you write your code in a text file, usually with the extension .py, and for a Python file. And when you run a Python code, Python interpreter looks at the text file and interprets row by row the statements on the text in the text file. Empty lines are ignored, so they're not interpreted. So you can see here, this is a typical Python code here. The hashtag here, this thing here, is actually a comment. This part here is a special thing for Mac and Linux users. It just tells you, the script tells you that it wants a Python 3 interpreter. You can ignore that, it's optional. The other part here is a bit more important. So Python can handle international characters. So if you want to write Swedish text in your strings or your variables, it's a good idea to put this thing in the beginning of the code, because that tells the Python interpreter to expect international characters. If you don't put that, you can still put in text, but it doesn't always look what you expect when you run it. So that's why you have this UTF-8. This is an international standard for how to handle international characters. So here's here a comment, and here you have our first Python code. So this is a for loop to repeat something a certain amount of times. So you see here for I, which is the loop counter. Range here gives you a range to loop over, in this case from 0 to 7. So Python always loops from 0 and 1 less than it says here. So everything in indexing is 0 based. So if you used MATLAB starts with 1 for row 1, Python 0. So that is the only thing you have to remember when you do matrices, that indexes start at 0. And then you can see there is a colon here. And wherever you see a colon in Python code, that means that now there is a code block. Just remember that. After this, there comes a code block. And a code block is always indented in Python. So perhaps you ask yourself, why is there a space here? Because that is important. So all code blocks has to be indented from where you define it. So the for loop is defined in this part here, and it's indented here. And that means that print I belongs to the for loop. So if I run this here, and then you can see here in the notebook, you can press the play button here. That will actually run the code. And you can see here, it goes from 0 to 7. And if I do a print statement here, where do you think this will end up? Will it go in the for loop? You're correct. So you can see here, it will end up after the for loop have executed, you will get hello. But if you do like this, I will end it here. You see here now it belongs to the for loop block. So indentation is important in Python. And that's why he said that he wanted to create a readable language, that indentation actually means something. So that will force you to actually indent your code, which is actually good for readability. So we'll remove this, otherwise it looks strange. And this is a notebook here, so you can see that every time I press the play button here, it will execute the code and show me the output here. Built-in functions. So Python is both a language, but it's also a runtime library. So if you look at the Python standard, it has the things like for loops, if statements, and stuff like that, but it also has a lot of functions you can call that are built into the language itself. So the first thing we will learn is the print statement. It prints out what you put in the parentheses. So in this case here, this is the function name, print. Then you have a parenthesis, and between the parentheses you can put parameters or arguments to print out. So in this case, print is a special function. It can take many arguments or any number of arguments. So in this case, I have a string here and I have a number. And you can see here it prints out, this is the print function and then 42. A function doesn't have to have parameters, and then but you still need to have the parentheses to call a function. So in this case here I have print. It will do nothing. Print an empty statement here, or empty line. You can also have functions that return values. So in this case you have a math function here, apps, and you assign that value on the left side. So y equals to a function called abs, parenthesis, and then it will assign the y variable, the value from the function. Something that you probably have seen in MATLAB as well is that you can have multiple return types on the left side. So a function can actually return more things than only a single variable. And this here is the divmod function. We return the quotient and the rest. And you can see here I have a comma between the parameters here. And it will assign both of them together here, so 2 and 6. So now we go into this dynamic aspect of Python. If you have programmed other languages like C, it will be a bit different. So in Python, a variable is a reference to a memory location. So if you do a equals to 1, 1 will be stored somewhere in memory in the computer, and a will be a way of accessing that memory location. So that is what the variable name is. It's like when you leave your coat at the restaurant, you get the ticket back. And the variable name is the ticket that you give to get the coat. And the same thing here, the variable name is the ticket to get the value in memory. And the value in memory can be a list, it can be a floating point, it can be a string, different things. So in this case here, there is also no type specified when you assign things. But important to know is that Python is not a typeless language. It's just that you don't have to specify. It will determine the type depending on what you assign it. So if you assign it an integer value, the variable will be an integer. If you assign it with a decimal point like this here, it will be a floating point. And if you assign it a string, it will be a string variable. And what we cover later on here, you can assign it a list, number of values, and then use the square brackets to do that. Then f is a list variable, points to a list in memory. And what you can do here is, again, so we see we define a here as an integer, and here we assign a as a string. So the same variable in Python can actually change over time, the type. So that's why dynamically typed. You can change the types depending on the execution. Yeah, this will not do anything. So before the break here, naming a variable. So there are some rules here that you should apply to is only use English alphabet letters for the variables. You can use numbers in the variables. No special character except underscore. And you can't start a variable with a number. It always has to be under a special character, like an underscore, or a letter from the alphabet. Variables are also case sensitive. So the case, if you have an uppercase letter and a variable starting with an uppercase letter, is different from one starting with the same name with a lowercase. So allowed variable names are here. We have first underscore name. It's perfectly fine. Last name, number, I2. But these are not okay. 1 var. So 1 starts with a number. That is not okay. L starts with a non-English character. But actually, a couple of weeks ago, I think that they have started to support actually variables that have international characters. But I think we should not go there. Keep them English, otherwise we will have problems. I think we take a break now, and then we continue with Python after the break. So a little bit more about variables. I touched upon this before, that variables are references to the underlying data. So when you assign a variable, what is happening is that memory is allocated for the value to be stored, and the name variable reference is created a variable, and then the variable refers to the memory for that value. So if you look at the code like this here, how A equals to 42, B equals to 84. If you look in memory, this is just a visual representation here. You have a variable reference A that points to memory location 42 of the value 42. B, a variable pointing to 84. So there are two different memory locations. But what one doesn't expect really is what happens when you do this. So at the first glance it looks kind of obvious. A equals to B. You print A, yeah, both of them are 84 now. But in memory it looks like this. There is only a single 84 stored. So both A and B points to the same memory location. So it's automatically handled. You don't have to think about it. And in most cases, you just code the way you think it works, and it works. There are certain things I will tell you that could be problematic, but I will go through them as well. And if I do A equals to 21, now A points to a new memory location, 21. And what happens here is also when a memory location doesn't have any references anymore, Python will clean them away. So if a memory location is kind of orphaned, it goes away automatically. It's cleaned up. So you don't have to think about it. It just works. You can actually check the memory locations of a variable by the ID function. And this is something you rarely do, but I will just show you that it actually works in the way I told you here. So I define two variables, A 42 and B 84. Then I print A and I do ID A, ID B. That will give you a unique identifier for that variable reference and what it points to in memory. And then I do the same thing here when I do the different operations here. So I run this code here, and you can see here that first we have two different locations, 84 and 28 here. A equals to B. Now you can see here both of them points to the same memory location. So 28, 328 at the end, 328 here at the end. I assign A 21, and now you can see A has 312 as memory location, but B is still 328. So just to show you that this is what actually happens. So data types in Python, we have already started using them. If you assign an integer value to a variable, it's an integer variable. Same thing with if you assign 42.0, it's a floating point value. You can operate on these using operators. Operators and expressions. So you have exponentiation, also 2 raised to the power of something. You can have unary operations, that is, you can put minus in front of a variable and then it negates it. You have multiplication, division, floor, and modulus. So multiplication, division, floor, and modulus. Modulus is the percent operator. You can do addition and subtraction, of course, and you have comparisons. So equals to, not equals to, less than or equal, greater and greater than equal, is or is not. You also have Boolean operators, not, and, or. So you can see simple operators here, 2 plus 2, an expression here. And also if the expression is floating point, it will return a floating point value. This was not the case in older versions of Python, which is if you have two integers and you did a division, it was integer division. But that is not the case anymore. So you see here that you will always get a floating point back. Even if there are two integer operators, it will return you a floating point. You also have a Boolean data type. So a Boolean is something that can be either true or false. And if you want to assign a true value to a Boolean, you have to use the true keyword. So this is a special identifier in Python that gives you assigns a variable, and then the variable becomes a Boolean variable, either true or false. And then you can assign false to assign the false value of the Boolean. And also, if you print a Boolean variable, it will print true or print false. So it will print that to the screen. Another really cool variable, which is, I think, one of the most used data types in Python ever, it's the list. So you can create a list that is a variable containing references to other values and other data structures. So a list can contain anything. Any data type that you define in Python can be contained in a list. And you can create an empty list just by doing an empty square bracket. That is and if you print that, it will just give you a square bracket. Then you can create and add values to the string by just assigning them like this, in a row like this. This will assign the list, and you can see here that you can have both floating point and integers and string mixed in a single list like this. You can access the values in a list by giving a square bracket after the variable and then the index for what value you want to access. So in this case, it's 2. And you remember we start at 0. So this is 1 here is 0, 1, 2. So we should have a 6 here when we run this. Yes. Also, assigning a list is very simple. You can do values 4, that is the index we want to assign, and that should overwrite 0, 1, 2, 3, 4. So the string here should be hop instead. And it was. Even more cool features is what happens if you put a negative index in a list. Can you think what happens? Yeah. Yes. So this is the quickest way of getting the last item in a list. It's just -1, and then you will get the last item in the list. So here you have 1, which is the last item here. And if you continue with negative indexes, you just go from the end back. So then we have -1, -2, -3. Should we have a 4 here? Like this. Also, if you access variables outside the range, Python will not be happy. So it will crash like this, listing this of range. So you will have an error when you access a list outside its range. So how does lists work? So same thing as variable, a list consists of references to data in memory, and the data is not stored in the list. The references are stored in the list. So you can see here, this is the list we had. Inside this list container, we have references to data in memory. And values is the variable pointing to the actual list container of references. So in this case here, we have a list, values, and we assign B values 4. So values 4 here is 1, 0, 1, 2, 3, 4. So that is the string here. And then we can print it out here and look at the ID of these. And you can see here that when I assign B values 4, you can see here that these is the same memory location. So a normal equal to a list here will not make a copy. It will actually reference the same value as in the list. So you have to think a bit careful when you do this with lists. So this is actually the situation we have here. We have values here pointing to the memory locations. We do B equals to values 4, and that points to this memory location here. So just be aware that this is something that can happen here. You can do copy as well. If you can explicitly say that I want a copy of that value as well. I will come back to that later. You can also do extract ranges from lists. So here you have ranges from 1, 2, 3, and this is a bit so intuitively you think that okay, index from 1 to 3, but in Python it's a bit different. So it's actually from 1, but not including 3. You can also do range from 1 to the end of the list. You can do values from 3 to the end of the list. This is obviously you can have all elements in the list, and that is similar to what you can do in MATLAB with arrays. You have this colon notation and range here. So here is the different visually here. This is all the values 1 to 3, so that is from position 1, 2, but not 3. 1 to -1, so that is all this value, but not the -1 here. 1 is from 3, so 0, 1, 2, 3 to the end of the list. Colon -2, so from the start, but not including the last 2. -3, colon on the other side, range here. So this is the way you can access different things in the list. You can get the size of a list by using one of the standard functions in Python called len. And len you can use on many different data types. So len will query a data structure for the number of elements in it. So if you do len values here, you should get back how many values we have in the list, in this case 7. You can add things to a list, and then you use the method called .append. So values is an object. We'll look at object-oriented program later, but objects have methods that you can tell them to do things. So in this case, I say values, append 42 for me. So append is the verb on the object, which we can add things to it. So if we do 42 to this, I get 2 here at the end here. So that's added to the end of the list. I can also use insert at a certain position. So insert after 1, the string squeeze. And you can see here that it inserted at position 1 squeeze and then moved all the other things to the right. So you can see now this is a quite powerful data structure that can do a lot of things. The things you shouldn't do with the list is actually numerical computing, but we will come to NumPy later on. So lists are for kind of handling mixed data types. We can remove things from the list. So here we have before remove, and then we can use remove, and then the name of the things we want to remove. And then after remove, you can see here that squeeze is gone. There's also a generic function in Python called del. So there are some functions that you will see multiple locations on multiple data types. And del is one of them. So here you can see I want to delete the first value of the list. Then I do del and then value 0. You can see here that 1 disappeared here after delete. You can also remove sub-ranges here. So I can do all items after 3 and I can delete those. You can see here that it deleted everything from 0, 1, 2, 3 and continue here. There's also, you can use it as a stack type. So in a stack you can push things into the stack and you can pop things from the stack. And there is a pop method. So I can say pop the last item of the list here for me. Or I think it's, sorry, let's see what happens here. So it popped the last item of the list here and returned it in the variable here. So that actually removes the actual value from the list, but it maintains a reference here by assigning v, the thing that you remove from the list. Okay, so then we have a full list. We want to get rid of the values. You can do it in some different ways. So if you do a equals to empty bracket, you will get a empty list. But what actually happens is that you assign a new list to the variable reference a. If you have other references to A here. So B equals to A, for example. A equals to empty will not delete the list. There is still a reference to that list. If you want to clear the items in the actual list, you can instead use the clear method. So here is the example of here. I have A here. I do B equals to A, and I assign an empty to the A, but you can still see that you have the list is still there. So now, but now B owns the list instead of A. A has an empty new list. I can do the same thing here. A equals to this list, B equals to A. Then I do A clear. Now you will see something happen here. Now B is also clear. So clear will actually clear the actual items in the list, but to keep the kind of list in memory. And that's why it works with B equals A as well, because both A and B points to the same list, and if you do clear on A, it will also clear the B list. And I told you can have anything in a list. You can have lists in a list. So you can have nested lists in different levels. Yeah.
If you clear by mistake.
Yeah.
Can we going back again?
No.
Okay.
There is no undo. So now when you have done the clear, the values are gone. There is no way, unless you have a no, you can't. It's you clear the memory of that list. And that's a problem with programming. When you do something like that, it's direct. Yep. You can have lists in the list. So here I have 1, 2, and then you have a list here as the third element, and then 5, 6. So here's 1, 2, 3, 4, 5 elements. And you see I can access, if I do A2, you can see I get a list back here, 3 and 4. I can assign values to a nested list by using double square brackets. So first I need to access the list item here, so that is 2, and then the first item 0 of that list. So you can see here I can do 2, 0, and then I access the internal list. So this way you can actually do two-dimensional data structures in rows and columns if you want. That is completely possible, which is actually what I'm going to do in this example here. So I can very easily create a spreadsheet. So spreadsheet, an empty list, which I will add rows to. And each row has a number of, a list for that row that contains the columns. And here is an interesting thing here. If you do, if we take a list with a single argument and use the multiplication operator, that will actually expand the list to 10 elements. So this is actually equivalent to writing 10 zeros. Then I just append those lists to the spreadsheet, and I can print it out, and I can check the len here. And len here will actually be 4, because I have 4 rows here. And then I can actually access the different items here by using first row, fifth element. So here you can see that I have 10 zeros here is the first row, 10 zeros the second row, and third row, and so on. So I now have actually a kind of an array data structure. And you can just to illustrate here what happens if you do this operator. So I have 5 here, which is a single item list. Multiplied by 6, I get a list with 6 elements. So this is actually a quick way of, if you want to fill a list with values, you can just do multiplication and then multiply the number of elements you want. Now we get back to this here with referencing variables again. So now I have a B equals to a list with 2 items, and I have A is a list with 1, 2, including the B, 5, 6. So here you can question, what happens if I do B0 equals to -1? Will that show up in A as well? Let's check. So you can see here I assigned B0 -1, and I assigned the other element -2 here. And you can see here that -1 is there, -1 is there as well, -2 is there as well. I only assigned it in one location, either in A or in B. So you can see here that this is the actual layout in memory. I have B, 3, 4. I have A here with a list with its own storage, and then it points to this list here. So that's why, so by default, everything is by reference. If you don't want this, if you want to copy, you can do that as well. And then you do like this, b.copy. That creates a new list with a copy of the old one, puts it in the other list here. And now there is no connection anymore. Now you can see here that I can change everything I want in B, but nothing will happen in A. There's still 3, 4 here. And this is what happens in memory. So I did a B copy here. That copied B 3 by 4. And B now contains its own, points to its own memory locations. So copy is a good thing if you want to copy and not a reference. Add .copy. Tuples. It's a strange kind of list. So a tuple is usually ordered, so it has an order of different things, of items. Another thing with a tuple that is different from a list, it can't be changed. So once you've created a tuple, the items in the tuple are fixed. You can't change them. And the difference between a list is that instead of square brackets, you now have parentheses. Why do we have this? The reason for that is that by having it read-only, it's much, much faster to iterate over a immutable data structure. So that is why. And also, it's also used in return values from functions are also returned as tuples, which you can't change. So read-only, you can assign them to other things and make a copy, but they are kind of read-only. So for example, here I have created a tuple here with items in it. I print it. I can print it just like a list. It works perfectly fine. A2 is 3. But if I try to change something in it, you can see here that, oh, Python is not happy. It says that tuple object does not support item assignment because it's read-only. So you can't change it. Once you have created a tuple, you can't change it. But it's actually not a really large constraint either, because it's really easy to create new tuples. So for example, here you can have A equals A plus 42. You don't change A here, but what happens here is that you create a new reference to a combination of a tuple A and you add a tuple 42, and this will work. But the thing is that you create something new. So you don't change A here, you add 42, create a new tuple, and the old tuple, because A is a new reference, again, reference a new data structure, so in this case it doesn't, that old data structure goes away and it creates a new tuple that you can't change. So it's not as restrictive as you will think. So here you can see you can add things to a tuple and create a new one. This is a bit inefficient to work like this, so you shouldn't do that. But it's less of a restriction than you think. Related to tuples, we have strings, and strings, they store text of different kinds. And Python is actually really, really good at handling text strings in many kinds. And you will see here that there are really many ways of creating strings. So the first thing here is that you create a new variable here, and the text that you want to go into string is enclosed by quotes. So you can have double quotes like this. It creates a string. You can have single quotes. Is equivalent, so they are the same. There are no differences between the string that you created if you have quotes or double quotes. The reasons for having both of them is that you can actually combine them. So if you want to use a single quote in a string, you can use double quotes on the outside. So here you can see, don't give up. You can see here that you can have the single quote inside a string here. You can also do the opposite around. If you want to have double quotes in a string, you can use single quotes on the outside, like this. You can also, if you want to have a single quote in a string that is enclosed by single quotes, you can use special control characters here. So if you have a single quoted outside string, you can use backslash and then the quote, just to kind of tell, I want a quote here, regardless of its outside here. So in this case, this will print a quote and double quote. There is a backslash n, which gives you a new line. You have backslash t, which is tabulation. And if you want to actually have a backslash in your string, you can do 2 backslashes. Then it will insert a backslash. Because obviously if you have control characters that all begin with backslash, you need to do something special to get the backslash in the string. Oh, that was complicated. So in this case here, I have another string here. You can see there's a backslash n character here. That is actually a new line. So when we print this string, the print statement will go to this backslash. Oh, I want a new line. It will go to the next line and continue from there. So all strings in Python has this ability to have control characters built in. So you can see here, if I print this statement here, it will print on 2 lines. So the first, before the backslash n will go here, next one will go here. If you don't want this processing, if you really want to say, please Python, ignore any control characters, I want to actually print the control characters, you can do that as well. And then you add a prefix r to the string. And R stands for raw string. That means that it will ignore any characters, control characters in the string, and print them out as well. So here you can see comparison between a raw string and a normal string. And you see the raw string actually prints the backslash n. Another cool string you can use is if you have something that you want to use as a template, a configuration file, a HTML file, or something that you want to print out with formatting. You can do that. So then you use a triple quoted string, it's called. So you can see here, I start the string with 3 quotes. Then I write my text just like with formatting, everything. So you can see here, I have a new line here, I have a new line there, but I don't need to use any control characters. I just do the new lines directly in the string. And if I run this, you can see it prints the string just like it was entered in the source code. So this is a really nice way of creating template files for different things that you want to write to file or print to the screen. Length of strings. So here we come back to this generic function in Python again. If you want to query the length of something, you can use the len function. So here I have 2 strings, and you can see here that it prints out the length of the strings. You can also do use operators on strings. So if you do plus operator, it will add the strings together, create a new one. And we already started with this. You can repeat strings, just like we repeated lists. We can use the multiplication operator to repeat a certain character. So in this case, I have a text here, and I want to do an underline in the text file here. So I do the dash character here, and I just multiply it with the length of S1. Then it should create an underline here that is the same length as a string. Another operation that is very common when working with strings is the ability to split the strings in multiple parts. So for example, if you read a file from the disk, it could be a text file containing numbers. You want to split the numbers into a list where you can interpret them. Then you can use the split operation. So I can tell the string split. Then it will return you a list with the items in the items separated with spaces here. So if you run this, you can see you get the list of the words in the string. So by default, it uses the space as the separator. But if you have values with commas in your files, you can do split, and then you can say that I want to split on comma instead. And then it will split it on the comma signs instead. It's also possible to go the other way around. If you have a list of words, you can create a string of those by using the join operator. This is that's a really unintuitive way of actually putting together strings. So what you do is actually you start with a separator, so space, and then you tell that separator, please join me with this list of strings. So this here will create a new string with spaces between the words here from this list. This will create a string with commas between the words, and an empty spacing here will just put them together without spacing. So let's see what it looks like. So you can see here the first one that adds a list of words. Then you have 3, house, pencil, eraser, and then you just put them together without spacing. So join is a nice way of combining things to strings. You can also search strings to see if there is something in the string that you want to search for. In this case, you can do, if I want to figure out if the word vocalia is in the string, you can actually use the in operator to check that. So vocalia in S will return true if vocalia is in the string. So let's see here if it's in. Yes, it says true. So this is a very quick way to check if there is, check for words in the string or certain items in the string. But that will only return the first item, so you don't get any position, you just get true or false if it's in the string. You can also use find instead. So find will actually find a word in the string or character sequence in the string, return the position of the starting point of that string. If it doesn't find it, it will return you -1. So you can have an if statement to check that. Then you can also continue searching from the last word position. So you do find, and then you can give it a starting position where it's going to continue to search. So if you run this here, you can see it found the first for at position 4. So you can see that one here. And then it found the next one, position 44 here. But it didn't find any Python here, and you can see it returned -1. You can do a lot of things with strings here. So next we will want to clean up our strings. So usual cases when you read from file, you will get strings that are kind of unformatted. You have spaces before the string, after the string. Then you can use the strip method to remove things from both the beginning and end. So if you run this here, you can see here that this is the original string. We have spacing here and here. After the strip, you can see that there is nothing in front of it and after it. Then we have special cases here. We have right strip and left strip, just what it sounds like. Right strip strips the right side of the string, and left strip does the other way around. Another thing also to remember, I think I didn't say, strings are, the strings have the same properties as the tuples, so they are immutable. So once you have created a string, you can't change the context of the string. But it's so easy to create a new string, so it's not a big problem that you can't change the string itself. But that is also for efficiency. As I said before, Python is a dynamically typed language, but it's not untyped. So just to kind of illustrate this, you can see I have assigned 4 variables with different types. And then there is a special function in Python called type, which will actually return the actual assigned type to the variables. So you can see here that 42 is an integer, 42.0 is a float, the true Boolean variable is a bool, and D is a string. So the assignment actually determines the type. Now to this, the one also very popular data structure in Python is called dictionaries. And it's a special data type where you, instead of having numerical indexes like we have for list, we can actually have keys. So we associate values with a key. And using this, you can actually do very quick searching for data in data structures. You create a dictionary just like you create a list, but instead of a square bracket, you use curly brackets. So here we have an empty dictionary with curly brackets. And we can create a new dictionary here by assigning. When you assign dictionaries, you always assign them in pairs. So you have a value here, a key here, and a value. So in this case, it's perhaps a phone book. You have a name and a number. So this is the key, Petra, and then colon, value. Then we have a key, David, colon, value. Ulle, colon, value. That creates the dictionary. So always you need to have a key and a value, and you have pairs of them. And you can see if we print it out, it looks like this. You access them just like you do a list, but instead of putting indexes, you put the actual key in. So if you want to have the value of the key David, you just put in values, key of David, and then you see you get the numbers back here. You can create new keys by just assigning here. So values Peter equals to a number. That will add Peter to the list here, or sorry, the dictionary. Also notice that the order is not necessarily the same order that you put them into the dictionary, because dictionary is it's a binary tree, so it doesn't necessarily store in the order that you put them in. The strong thing with a dictionary is you can find things here. So in this case here, I have a dictionary index, and I can check if a key is an index just by doing Petra in index. That will return true or false. In this case, Petra is here, but Busse is not, so we should have first a true and a false. Then we have, same here, you can determine the number of elements in the dictionary by using the len. And yeah, we have all done that. And you can also do really complex data structure by combining dictionaries and lists. So you can have a dictionary with keys that contains lists or strings in a structure like this. I have a config file for a program, for example. I have a general section. I have what's called constants here. Constant section, and I have items, constants here. I have items. Then I can access them like this. So I can access config general username. That will go into the general section here and give me the nested dictionary here, username. I can give items, values, and for a second item here, so 0 and 1 in the values list here. So I have a list inside stored in a dictionary key. So there's no really necessary to invent your own data structure. You can create them by using combining dictionaries and lists. So here is actually a part where you can try yourself. If you want to show the solution here, you can click show code, and you have the solution here. So I'll give you a couple of minutes here now. It's to just, if you try yourself, if you can create a variable with the value 47, a string with it's fun with Python, and a variable with 42, and then print the value of A, and create a list variable L containing the values 4, 6, and 32. So you can, I give it a minute. You can do it at your home later as well.